What is the value of? Okay, well, let's just do this manually. The first one is going to be, let's see here, that number with a little over a million. And the next one is 999,999. And then when you subtract those, you get 2. So the answer is A. A model used to estimate the time it will take to hike to the top of the mountain on a trail is of the form T is equal to AL plus BG, where A and B are constants. T is the time in minutes, and L is the length of the trail in miles, and G is the altitude gain in feet. The model estimates that it will take 69 minutes to hike to the top of the trail if a trail is 1.5 miles long and ascends 800 feet, as well as if a trail is 1.2 miles long and ascends 1,100 feet. How many minutes does the model estimate it will take to hike to the top if the trail is 4.2 miles long and ascends 4,000 feet? All right, so we have to basically convert the words of the question, the sentences, into math. Okay, no problem. The first part of it, I believe, would be 69 is equal to A times 1.5 plus B times 800. Just basically, I think it's this sentence right here, that one. And then the next sentence would be 69 is equal to A times 1.2 plus B times 1100. And that is this sentence right here. Okay, so we got two equations, two variables, so we should be able to solve this. And I guess at the end we would be able to figure out this one, which would be T is equal to A times 4.2 plus B times 4,000. So obviously we're going to need to figure out what is A and B. Okay, no problem. So here we go. I'll do 4 times equation 1 minus 5 times equation 2. And that will give me 276 minus 345. That will give me, let me think about this, 6A plus 3200B minus 6A minus 5500B. Yeah. And then that would mean minus 69 is equal to the intentionally doing this to ensure that one of those variables cancels. And that's minus, hold on here. What did I do? Sorry, there's one more zero. Good thing I caught that. 2300B, and then B becomes 0.03. Okay, and then when you sub this back into any one of these and solve for A, you'll get A is equal to 30. So coming back, let's just keep this all on the same screen. It would be 30 times 4.2 plus 0.03 times 4,000. And when you crunch out those numbers, you will get 246. And that would be choice B. The number 2024 is written as the sum of not necessarily distinct two-digit numbers. What is the least number of two-digit numbers needed to write the sum? The least number. Okay. The least number. So, two-digit numbers range from 10 to 99, right? So if we want 2024 to be the sum of a bunch of two-digit numbers, all the way, then we want the numbers to be as big as possible, because that way we would have the least number of two-digit numbers, and the biggest number is 99 of this range. So a whole bunch of 99s, and then eventually probably something left over. So I think if you do 20 of these 99s, you would get sufficiently close to 2024. 20 times 99 is what? 1980. So, and then we have to add another number, so I'd have to add 44, correct? Yeah. So how many numbers? I used 20 of the 99s, and I used just one 44. So I had 20 of the 99s plus 144, so I use 21 numbers. And that is basically the answer to the question. What is the least value of n such that n factorial is a multiple of 2024? So n factorial is 2024 times some k. It's a multiple, right? So the first thing I think that will be helpful is to convert this 2024 into its prime factors, prime factorization. So I believe it's 2 times 2 times 2 times 11 times 23. And then we get that k. So that's n factorial. So we have to figure out the smallest value of n. Well, the smallest value of n would have to have at least these guys in it. Correct? Yeah. The smallest value of n factorial is what I should say. Okay, well, let's see. How about 23 factorial? It would have the 23 times 22, dot, 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 right? And then eventually you'll get to an 11. And then eventually you'll get to an 8. So that 23 is covered. That 11 is covered. And this 2 times 2 times 2 is 8. That would be covered. So I think that, and the k, we can just make it 1. Because that, I mean up here, hold on. This k, we can just make that 1. We don't need, because it just says a multiple of 2024, right? It doesn't necessarily say that it has to be 2024 times 2 or times 3. So if k is 1, that's sufficient. So I think 23 factorial, yeah. So that would be D. A data set containing 20 numbers, some of which are 6, has a mean of 45. When all the 6s are removed, the data set has a mean of 66. How many 6s were in the original data set? Okay, so we've got a whole bunch of numbers, A1, A2, and so on, all the way until A20, right? Because there's 20 numbers. And they're saying that the mean, so divide by 20, is 45. So that basically means that this entire sum would be equal to 20 times 45, which I believe is 900. Now that sum, though, is in two groups. There's the sum that I'll just call sum of a whole bunch of A's that do not consist of any 6s. So no 6s in this sum. And then you have another group that is all 6s. And that, the sum there would basically be 6n, where n is how many 6s there are. Correct? Okay, so then the total sum, if you go back here, would basically just be this guy and this guy. I just broke that up into two parts, this and this. So I'll just call it sum plus 6n, and as before, this total is 900. Okay, so now we get to what they want and what they are asking for. They're saying if you take out all these 6s, you remove them, then the mean is 66. So basically what that means is that if you just take this and take its mean, it would be 66. Now, how many are we going to divide by? Before we divided by 20, but now we're going to divide by 20 minus n, right? Because there's n 6s, and we're taking out those. So I guess we have a system of equations here, and we'll just solve for it. So from this guy, sum is basically 900 minus 6n, and therefore that would be 900 minus 6n all over 20 minus n, and that's 66. So that means 900 minus 6n is equal to 1320 minus 66n, and this looks to me like 60n is equal to 420, and therefore n is equal to 7. There are 7 of those 6s in that original data set, so the answer here is D. The product of 3 integers is 60. What is the least possible positive sum of the 3 integers? Okay, so we have 3 integers. Let's call them A, B, and C, and their product is 60. Now 60 itself is 2 times 2 times 3 times 5. So let's experiment with this. Let's say the numbers are 4, 3, and 5. That means the sum of these would be 4 plus 3 plus 5, and that, of course, is 12. And 12 is actually not one of the answers, interestingly. Okay, let's experiment again. Let's try 2, 6, and 5. Right? If you get this is 2, this 2 times 3 is 6, and then that 5. That the product would, of course, be 60. And the sum would be 2 plus 6 plus 5. And that is 13. 13 is one of the answers. But they want the least. So I have to figure out, could I get any of those? I got this, but there's 4 answer choices that are smaller. And I think that could be achieved if some of these numbers are negative. Meaning, it doesn't actually say that the 3 integers have to be positive. These integers could be positive or negative, right? Because it doesn't specifically say they have to be positive. It does say that the sum has to be positive. Okay, so let's experiment with some negative numbers. Let me think about this for a second. What negative numbers? How about, let me write this out again. It's 2 times 2 times 3 times 5, right? But it could be, let's say 2 times 5. Then it could be 2 times 6. Sorry, 2 times 3. And then we could add just a 1. And that way, I'm pretty sure we could get something smaller. So this is like 10 and 6 and 1, right? But if 2 of these are negative, like for example, if it was negative 6 and negative 1, we would still get a product of 60. So this would still be valid. And therefore our numbers actually are 10, negative 6, and negative 1. And when you add these, you actually get 3. And 3 is actually the smallest positive sum that you can get with this type of experimentation. In triangle ABC, angle ABC is 90, and BA and BC are root 2. Points P1, P2 until P2024 lie on hypotenuse AC, so that AP1 is equal to P1, P2, and so on until P2024C. What is the length of the vector sum BP1 plus BP2 all the way to BP2024? Okay, well, first let me draw the diagram. And I am not sure why I drew it on a coordinate scale. That's just a habit, I guess. So here we go. This is A, B, and C. And obviously this is not going to be drawn to scale, but I just wanted to illustrate what they're talking about. So they've divided the hypotenuse, obviously, into 2024 points. And so this is like P1, and this is P2, and so on. Now obviously, it's not drawn to scale. And then each of these vectors, so the first one would be from here to here, like that. And that's supposed to be a straight line. And similarly, all the other vectors are going to be a line from B to that point. Those are called vectors. And if you're not familiar with vectors, I will try to kind of explain how they behave. And then what they're saying, once you've drawn all those lines, all those vectors, you add them all up. And then what's the sum? Okay, so how you would do this, obviously you're not going to draw them all in and take the measurement of each one. That would be way too long, because there's how many of them? There would be, well, this sum actually is 2,024 different vectors, so way too many. So what you do is you analyze what actually would be the sum. So again, I've got to draw this diagram to kind of illustrate. So here we go. Again, A, B, and C. And I will draw a dashed line to kind of illustrate. So that's kind of completing that rectangle. I think it's a rectangle. I don't think it's a oh, no, it is a wait, is it a square? Yeah, it's a square, because this is root 2. This is root 2. That would be root 2. That would be root 2. It's a square. Okay. Yeah, because BA and BC are both root 2. Okay, now what I'm going to do is I'm just going to draw in two vectors that are opposite each other. What I mean by opposite is, like, for example, this guy and this guy would be opposites, meaning they're equidistant from the opposite ends. P1 to PA would be the same distance as P2024 to P2024C. You see what I'm saying? Which actually is written up here, right there. So let's just do that. Let's just do that. And it could be any vector, but we can just use those two vectors. And of course, as I keep saying, this is not going to be drawn to scale, but I'm just doing it to illustrate. So let's say you have the first guy, that's B to P1, and then you have the second vector, which would be the one that is equidistant, so I guess it'll come to here, right? Yeah. Okay, so what did I just draw there? I drew from B to P1, and then I drew B to P2024. Now what I'm going to do is this vector that's going from B to P2024, I'm going to superimpose it and kind of just push it up a bit. Push it up a bit so that it lands here. I'll just draw it like that. You see what I did there? I just moved it up. And what that allows me to do is, on the graph, it allows me to show you what BP1, let's complete it with the vector signs, plus BP2024 would equal. And I say, okay, well, how do I figure that out? Well, you just draw a vector. Let me use a different color here. From the origin to the endpoint. So that would be from B all the way to the endpoint. And that green line would basically be the answer. And how do I figure out the green line? Well, that's just Pythagoras. You've got root 2 squared plus root 2 squared is equal to that green line squared, which is, I'll just use V for vector. And that's going to be 2 plus 2 is equal to V squared. So that means V squared would be 4, so V is 2. So there we go. Now you say, okay, well, how does that help? Well, you can keep doing that, extrapolate that. So for example, BP2 plus BP2023 by the same principle would also be 2. In the same way, it would be 2. And so on. BP3 plus BP2022 would be also 2. And then you keep going. And eventually you get to the very end, which I think would be 1012. Yeah. And then BP1013, that would also be 2. And then if you add up all these guys, that's going to be the total, which is what they want up here. That's going to be all the BP1 all the way to BP2024. And so BP1 all the way to BP2024. And that's going to be a whole bunch of 2's. How many 2's are there? 1012, I believe. And that is 2024. So there we go. 2024 is the answer. So there, that would be D. How many angles, theta, with theta between 0 and 2 pi inclusive, satisfy log of 3 theta plus log of cos 2 theta is 0? Okay. Well, just really quickly, I want to refresh my own memory. The log, sorry, not the log, just these graphs of sine and cos. This is theta and this is sine theta. And this is 2 pi. This is, that's pi. Oh, sorry, pi over 2. And this is pi, and then, of course, the intervals are 1 and negative 1. And then for sine, the cos theta, it's one of these kind of situations where, again, this is 1, negative 1, 2 pi is here, and then I guess this would be halfway, which is pi, and then so on. Okay, so I just wanted to do that. It's helpful to refresh anybody's memory. Okay, so here we go. We've got this equation. The log of sine 3 theta, and then we've got plus the log of cos 2 theta, and that all equals 0. Now, we're going to use some log rules You guys know about log rules, right? Log rules. So the one in particular here is looks like to me log of A plus the log of B is equal to the log of A times B. So that means this is the log of sine 3 theta times the log, just the cos of 2 theta is equal to 0. Right? Just using that log rule, nothing fancy. Okay, so then this was base 10. When they don't write in a base, it's assumed to be base 10. We can write it in if we want. So simple log rules would say that 10 to the power 0 is this sine 3 theta multiplied by that cos 2 theta. So that's 1. So the 1 is equal to the sine of 3 theta multiplied by the cos of 2 theta. Okay, so at this point, what do you do? Well, now we have to go back to the graphs, or even if you didn't remember the graphs, it doesn't matter. You don't really, as long as you remember the fact that the sine of something, whatever it is between 1 and negative 1, as the graph correctly illustrates. And similarly, the cos of something is also between 1 and negative 1. So that means that these guys are between 1 and negative 1. And when you multiply them together, they equal 1. So what are the possibilities? They could both be 1, or they could both be negative 1 each. I can't think of any other possibilities because you need an integer, right? Because, for example, if the first one was, let's say, 0.5, the second one would have to be 2. And you can't have 2 because it's only between 1 and negative 1. So that's why those are the only two possibilities. Okay, so then we kind of just explore these. Let's go with the first one. That means that the sine of 3 theta is 1, and the cos of 2 theta is also 1. All right, so let's see what we get. If that's the case, that means 3 theta, and it's always helpful to draw the graph. That's why I did it. Pi over 2. That means theta is pi over 6. Okay. Now let's go to this guy. If cos of 2 theta is 1, now we're looking at this graph over here. That means 2 theta is either 0 or 2 pi. That means theta is either 0 or pi. Well, this and this have no common solution. So, no solution there. Okay, not an issue. Now we have taken care of this guy. Now let's turn our attention to this guy. That one says that the sine of 3 theta would be negative 1. And the cos of 2 theta would also be negative 1. Now before I continue, remember up here we are actually trying to take the logs of those guys. So if we actually were to substitute these two things up here, it would become log of negative 1 plus the log of negative 1 is equal to 0. And that falls apart. Why? Because you can't take the log of a negative number. If you did the log of negative 1, that's undefined. So that falls apart. So this is invalid. So that's invalid, and this has no common solution. So there's no solution to this equation up here. So when they say how many angles theta between that range, the answer is 0 actually. So that would be A. Let m be the greatest integer such that both m plus 1213 and m plus 3773 are perfect squares. What is the units digit of m? M plus 1213 is a perfect square, so I'll just call it n squared. And m plus 3773 is also a perfect square, so we'll just call that k squared. And then if we subtract them, k squared minus n squared would be m plus 3773 minus m minus 1213. And k minus n, k plus n is the factorization there. And then the m's would cancel, interestingly. So that would be 2560. Okay, so, oh boy, so what do but m, we want it to be large as possible. So we want to maximize m. And to maximize m, we need to maximize either k or n, because they both, if you maximize m, you maximize n or k. So n and k, I guess. Okay, so, oh boy. Let's start with k. I'm just wondering which one should I start with. Does it even matter? But let's just start with k, since it's k minus n, k plus n. So what I have to do is I have to break up 2560 into possibilities. Well, there's one possibility, 2560, and I want to keep the numbers as large as possible. The next one is 1280. Yeah, and then there's many, many more. But we want to keep these numbers as large as possible in order to achieve that maximization. So let's start with the first one, when k minus n is 1 and k plus n is 2560. So 2k would be 2561. This is not going to work because it's not an integer. Because k squared has to be an integer. Yeah, because they're perfect squares. Okay, no problem. That one didn't work, so let's try that one. K minus n is 2. K plus n is 1280. And then 2k would therefore be 1282. And then k would be 641. Correct? And sub it back into here, I guess. And then n looks to me like 639. Right? Okay. And then I can figure out m. See, I can use either one of these. So for example, if m plus this guy right here, 1213 was n squared, and then n we know is 639, and then we can easily calculate the value of m. And when you do, you get m is equal to 407108. Now you can do the same kind of calculation with this guy if you preferred to use the K641, and you can do that on your own to see that you get the same answer for m. And what do they want here? The units digit of m. So the units digit is the last digit there, so that would be 8. 8 is the answer, and that's E. Let alpha be the radian measure of the smallest angle in a 3, 4, 5 right triangle. Let beta be the radian measure of the smallest angle in a 7, 24, 25 right triangle. In terms of alpha, what is beta? So let's draw some of those triangles. So this will be my 3, 4, 5 right triangle, and alpha, right? So alpha goes in there. Then I have another one that is a 7, 24, 25 triangle, and beta is the angle, this guy. And then what? Then I have to get alpha in terms of some beta. Okay, I understand. All right, so how do I do that? Well, I guess we have to use trigonometry. I'm not sure what else to use here. So let's start with the cos of beta in this triangle. So the cos would be 24 over 25. And then I think I can manipulate that and use that angle to put in values in terms of alpha. So 24 over 25, initially I see that as 2 times 12 over 25. And then that 12 can be divided into 3 times 4, and the numerator 5 and 5. Okay, so that can be, the 3 over 5 is actually the sine of alpha. Yeah, and the 4 over 5 is the cos of alpha. Okay, so we got from there to there. That's pretty good progress, right? So if the cos of beta is equal to 2 sine alpha cos alpha. Okay, so now we need to incorporate some trig identities. Trig identities, and you guys remember there's a whole bunch, right? But fortunately, I think we only need to use some of the more common ones. This guy over on the right side is the equivalent of sine 2 alpha. Yeah, that's actually a pretty common one. And then there's another trig identity, which I'm sure you remember, that the sine of alpha is equal to the cos of 90 minus alpha. So if I put that in, then this would be the cos of 90 minus 2 alpha. Okay, cos of beta is equal to the cos of 90 minus 2 alpha, so that basically means that beta is equal to 90 minus 2 alpha. And let's see the answer choices. They're using radians. Okay, no problem. I just have to, that 90 is really pi over 2 in radians. So there we go, pi over 2 minus 2 alpha. So beta is equal to pi over 2 minus 2 alpha, and therefore the answer is C.